Hello everyone, Eric Chappelle, Civil Community Evangelist for Autodesk, and with me today is John Rodriguez, Technical Account Manager, focused on utilities. And he is going to be the star of the show today, our primary speaker. But before we get to John's presentation on visualization with power engineering projects, I just want to talk to you a little bit about our webcast series and our community and some things like that. If you're new to the webcast series, we've been doing this twice a month for just over 2 years, so this program's been going on for a while. This is the product team webcast series, so we typically feature folks from the product team, but every once in a while it's nice to have a guest presenter from other parts of our organization, and that's the case today. Normally we get the internal look from the product team, the folks making the products, but today we're going to hear from John, who gets to work with some of our major customers, specifically in the utilities part of our business. So you're going to see some real-world examples today. But the goal behind the webcast series is to get you information about our civil products, primarily Civil 3D and InfraWorks 360, but other products come up as well. We've talked about ReCap and Revit and lots of others. It's a chance for you to ask questions and provide feedback, and it's also a way to just bring you guys closer to Autodesk, the folks making the software. So hopefully we'll accomplish all that today. I'm confident that we will. Our next webcast is going to be held on Wednesday, May 17th, so 2 weeks from today, same time, 12 to 1 Eastern. This is going to be a really exciting presentation. Also, another guest presenter, actually from the company named Kinetics. They make the geotechnical module for AutoCAD Civil 3D. So if you've ever used that module, it's really powerful, really robust. If you haven't ever checked it out, you definitely should. There's a major update to that module coming out very soon, and Gary from Kinetics is going to talk about the details of that and some of the amazing things you can do with that module. So definitely don't miss that. Again, 2 weeks from now, May 17th, 12 to 1 Eastern. You'll be seeing information in your email and on the forum and Facebook, Twitter, LinkedIn, social media about that, how to register for that webcast. Probably today or tomorrow is when that will start showing up. We'd like to take this opportunity to ask you a favor. We'd like you to enter, if you've got ideas of topics that you'd like to see in this webcast series. You have a questions window that's part of your GoToWebinar interface. If you could please enter into that section any ideas that you have for topics. I actually have the questions window open right here. I'm going to slide it over to another monitor, and we'll be watching that throughout the webcast. So if it doesn't pop into your mind right now, don't worry about it. If it pops in 15 minutes from now, please go ahead and enter in your ideas for future webcast topics there. And we will do our best to get you guys what you'd like to see. A couple of polls that I'd like to prompt you for some more information. First thing we'd like to know is, what's your current usage level with InfraWorks? I'm going to launch that poll now. And if you could please provide your answer. When we get up to about 75% of you have answered, I'll go ahead and close it down. I'd love to have better response than that, but let's try to get it up to about there. I'll give you kind of the play-by-play on the results. Right now, the winner is I regularly use it on some projects with 28%. 26% I've dabbled in it on a few projects. 19% I've installed it and played with it a few times. 15% I use it on almost every project, and 13% I don't even have it installed. So it's good to see always good to see some new customers on the webcast series that maybe haven't tried InfraWorks yet, or only been toying with it a bit. All right, I'm going to close that poll. Thanks to everyone who voted. And I've got one other poll. Those of you who do use InfraWorks 360, what do you use it for? Site design, road design, GIS data compilation for early project planning, residential design, or visualizing projects. I would expect to see a pretty heavy response to visualizing projects with the title of our webcast today, but we'll see how it plays out. And that was a good guess. I should have placed a bet on that one. We've got 78% of you that say visualizing projects is one of the things you use it for. Keep in mind you can pick more than one answer with this poll. So when I give you the percentages, they're not going to add up to 100%. So don't think I'm horrible at math. Visualizing projects right now is 79%. Next is GIS data compilation, 46%. Road design, I'm sorry, 57% was site design. That's in second place. Interesting. 47% GIS data compilation, 41% road design, and 17% residential design. Thanks for your answers on those polls. Moving right along, I just want to tell you guys about our civil engineering community. Right now the URL is autodesk.com/InfraWorks360 community. We need to do some adjustment with that URL because if you were watching the last webcast, we actually don't include 360 in the product name anymore. And also the community is actually not just unique to InfraWorks anymore. It's the civil engineering community, and we cover stuff on Civil 3D, InfraWorks, ReCap, Revit sometimes, Navisworks. If it relates to Autodesk Civil products in any way, you can find it up here. And this is a great central hub for lots of different information regarding the civil engineering community at Autodesk. The user forums, idea stations where you can submit ideas for how you'd like to see the products improved, tips and tricks, the gallery where customers like you have submitted their projects for folks to look at and comment on and ask questions. It's a great place to get ideas on all the different ways that other people like you are using our software. Things you never thought you could do with the software you'll see in the gallery. And then you can ask questions, you know, how did you do this, or why did you do it this way? It's a really great experience. Love the gallery. There's streams of different social information up there from social media and from blogs. Plus we've got an extensive video library, including all of the past recordings of webcasts in this series. So we've been doing this twice a month pretty regularly for 2 straight years. That's a pretty nice library of webcasts, and we've recorded them all. So far, I have I'm batting 1,000. I haven't forgotten to record one, including today. So you will see today's recording posted up here as well, probably later tomorrow. I don't believe that John's going to cover anything that's in labs or in a preview of the product, but just in case it comes up or if somebody asks a question, you should know that anything regarding preview features or labs features in InfraWorks or any software is not a promise of something that you'll see in the future. Don't make purchasing decisions based on that. Basically, unless you see it in a fully supported version of the software, there's no guarantee that it will be in a fully supported version of the software. And I think that's it for my segment. I'm going to turn it over to John. I'll be back right at the end to shoot you a reminder about the next webcast, but I'm going to make John the presenter, and he'll take it from here. John, the floor is yours.
Thank you, Eric. I'm excited for that geotech module session. I just introduced that to one of my customers recently and found that to be a great fit. So always exciting. As Eric has said, my name is John Rodriguez. I am Technical Account Manager. I work with named accounts, and I'm focused on utilities, electric and gas. And I want to thank Eric for providing this venue for us to look at InfraWorks. And we're going to actually look at more than just InfraWorks. And just for you, Eric, nothing that I'm showing will be out of labs or not current products. So this is all technology that everyone should have access to. So let's get into this. I apologize for the slideware at the beginning here. We will go into programs, but I want to just kind of prop this up because there's a lot here that can be of value, and I'll make this presentation available afterwards if necessary. So let's go ahead and take a peek here. So I have a value proposition here for an industry that has been very much under pressure to deliver what we call reliable, sustainable, and safe power, and to customers who are very demanding. I mean, electric utility, that commodity is in high demand based on everything we have today, electric cars, and you name it, everything's powered by electricity. And so I wanted to look at Civil 3D, well, Civil 3D too. I wanted to look at InfraWorks and see, could this software solution that can integrate data sets from multiple sources, could that be something we could introduce as a daily workflow tool? And if so, how would those realistic 3D models help you with sharing your projects, your project design intent to the executives and project partners and stakeholders that you work with day in, day out? And then ultimately, could these 3D digital modeled transmission distribution networks help designers analyze and assess project alternatives? And so that's kind of the focus here. Again, bringing these utilities to life. You know, seeing them in 2D is one thing. We do work primarily with 2D in the electric industry today. What does the future look like for the electric engineer of the future designer? Before we get too deep into the program and into the processes and some samples and examples, really this process has been defined, and I would say even refined over the past 2 years. I've spent the last 2 years focused on utilities. But I came out of the land development space, working in AEC, working with civil and surveyors, primarily developing BIM approaches. And so this process of how we would do this has been kind of simplified. And we've kind of refined this down to 4 steps. Defining your project area. Most of the time, our utility customers have very large project areas. They probably expand beyond most of the customers within the Autodesk user base, because we're talking about hundreds of kilometers, hundreds of miles of utility area. So you have to define your project area. We certainly probably wouldn't want to define our entire network in one model, so that's something to think about. And then what we want to do first is start up with what is the as-is conditions. And a lot of times that's gathering data that we already have, existing terrain data, or we might have a lot of GIS layers. Many times these GIS layers are siloed, so bringing them together into a single source location can gain valuable insight. We also have high-resolution imagery, and we have the ability to also bring in information around easements and parcels, and then start to define or design or lay out our design conditions. And those can be very much pole designs coming from programs like PLS CAD, which is very highly used in the utility space. We run into that program quite a bit, and it serves a specific purpose that we want to be able to leverage that data, extend that data. And and so then we want to also introduce other data like underground utilities and start to continue with that, and including LiDAR data. So we're going to look at that, and then of course finally creating design proposals is going to be a very necessary output of all of this. So as we look at the solutions, we are going to look at InfraWorks 360. We're also going to look a little bit at Recap 360. If you haven't heard of Recap, that's our LiDAR processing software solution. And of course, Civil 3D, which is my heart and soul. I've been using Civil 3D since its inception back in 2004, I think. So that kind of dates me. In fact, I've been using Autodesk products since 1988. So as I look at these 3 solutions, Civil 3D, Recap, and InfraWorks, those are probably the most exciting software solutions that I've seen on my desktop in any time. So let's look at this. So one level of looking at a utility would be at a high level. I would call it like a 1,000-foot level, and that would be called a planning level model, where we're going to start with Model Builder, which if you've ever built models with InfraWorks in its previous incarnation, as it came out of labs, the process was pretty tedious. You would have to go extract this data. You would have to clean it up sometimes. We've kind of taken that process, which was potentially hours, and brought it down to minutes. So we're going to be able to kind of look at that and process, and then from there start to overlay your own data, in this case GIS layers. We're going to look at that. More importantly, we're going to look at design level models, where we're bringing in very high resolution 3D designs coming from substation models, power poles, transmission poles, and detailing out that design. And from there, we're looking at a large list of data. The list extends. It's continuing to grow. We'll look at LAS data. We'll look at PLS CAD data. we'll look at Civil 3D data, including underground and site design. The reality here is you're going to save time, you're going to save money, you're going to be able to have insight, and you're going to be using data you already have in most cases to build these out. So we're going to look at that. And then, of course, once you have those models, and we'll look at this as well, we'll look at how easy can InfraWorks produce output files. How can you analyze it through sun and sky effects? You know, how could you get still images for your presentations, or just output a camera animation? And so, in many cases, we're not experts at video production, so you don't have to be an expert in InfraWorks. It's a very intuitive software solution, so if you've used it, you know what I'm talking about. And if you haven't used it, you're going to learn real quickly that it's pretty intuitive, quite simple to output these files. So we'll look at this as well. And then finally, well, not finally, but one other area that becomes very important is to be able to actually get some answers around your designs earlier in the process. If I can find out volume calculations earlier in the process, if I can measure distances for clearances, these are going to be very much valuable at an early stage to be able to see that, present it, and also socialize that. So speaking about socializing, one of the extended values of InfraWorks for the utilities is to be able to actually publish the models out to users from all different areas of the business. Your contractors, your construction managers, support, maintenance, to be able to go and look at these models on an iPad, take them up to the field, to actually review and look at that from several different angles. So we'll look at that as well. So last thing here I wanted to show on the slideware is that your model in InfraWorks does not stop at InfraWorks. From an early stage 30% design, you then take that and continue the job into Civil 3D, where we do our detailed design, where we produce documentation, where we can evaluate and analyze cut and fill volumes at a higher level, higher resolution, and then ultimately circle that back or round trip it back into your InfraWorks model and present it to your stakeholders to actually present your design intent. So let's take we'll look at benchmarking later. We'll take a look at the program. So I'm going to go ahead and drop this down, and I'm going to go ahead and jump into InfraWorks here. So I have 45 minutes on the clock here left, so I'm going to keep my eye on that as we move through this. Eric, you'll probably help me if I go long, hopefully. So the very first way that I would start a project today in InfraWorks is going to be straight out of Model Builder. And Model Builder is very much enhanced the beginning process of a project. In fact, a lot of times if I need terrain data from an early stage, I'll go to Model Builder, grab a piece of data, bring it into Civil 3D, and start to do some early stage work. But now I can do so much in InfraWorks, I actually do a lot more here, then move it to Civil 3D. So in this case, I'm going to look at a location just for sake of no reason at all. We'll just grab a spot. Let's just, we'll grab Las Vegas, let's say. So you grab a location, you'd be able to then perform a limits of your project. So where do you want this to be? So we'll go ahead and pick an area, let's say right here. As I use Model Builder, one thing to keep in mind, and one thing that I'm always conscious about is how much area have I selected? So I'm looking at about 18 kilometers, 17 kilometers. I can actually extract in one single model up to 200 kilometers maximum. So that's our maximum level. And what kind of data do I get from the Model Builder services? I'm going to potentially receive OpenStreet highway and railway data sets. I will potentially get building data sets coming from OpenStreet map data set, imagery, and this imagery is coming from Microsoft Bing Maps, which is going to be then draped over your terrain, and then finally your elevation data, which is also terrain data coming from DEMs at 30 meter, basically USGS level data. So you're getting high resolution information. You can search by location or you can search by map search, and then you would just give your project a name. So I might call this East Las Vegas data set. And I'll just go ahead and create that model. We have the ability to push these into specific groups if you're working with a specific organization or if you have groups that you want to share with, and then go ahead and create that model. So while that's occurring, it's going to happen behind the scenes, we can go ahead and do other work. So in this case, let's just pretend that we have moved into this project, which is also began from Model Builder, and let's bring some data in. Let's start to overlay on top of the Model Builder. So initially from Model Builder, I may receive information around imagery. I may receive maybe water areas, buildings and roads. In this case, I've turned the roads off because I didn't want to see the roads so much. I just want to overlay this on the imagery and the terrain. And so I'm going to go ahead and bring some data in. Now, a couple different ways I can do this. I can go from the Data Sources tab, which opens up my data sources, or I could just drag and drop some data sources in. So if I have a set of data sources that I want to bring in, I'll just go ahead and grab them. In this case, I have some layers here. I'm going to go ahead and grab some easement data, overhead structures, some parcels, maybe some other conductors, and we'll just go ahead and drop that in. As you drop in this data source, you then have the opportunity to configure that data. So for instance, I'm going to take the parcel and configure that parcel data. So what I normally do is I would name this parcels. I would provide a category within this database that's being built. So basically InfoWorks is a SQL-like database, and I'm adding data to this database, and I can categorize data. So it's really GIS at its heart. And so I can grab a parcel set of type. I can double check its geolocation. Of course, coordinates are very, very important as you're bringing data together. And then we can style this. If you've used Civil 3D, you've heard the term style. This is very similar. We have styles. So I could have different types of styles to provide here or put on top of this. In this case here, I'll just do I was thinking I was going to get a different area here. Let's go with, I'm going to cancel that for a second. So I'm bringing in as, I'm going to do a coverage area. I'm going to change this to coverage area. Usually I do parcels. I'm going to change this to coverage area just for now in this case, because then I'm going to have different sets of types of coverage areas and zoning. In this case, residential. So this is a style that I have. I'll go ahead and close and refresh that. And a coverage area basically is it could be a parcel you receive from Civil 3D or from a GIS database, but basically there's my information showing my parcels in a specific style. We can go ahead and bring in maybe the easement data. Let's go ahead and configure that also. In this instance, I'll just go ahead and do it the same way. I'll say it's easement, ESMT is fine. We will go ahead and say it's a coverage area. Again, checking my location, my geolocation, and then styling it. I don't have an easement, but I'll just take this agricultural style. I could always rename that style later and bring that in. And as I bring this in, I can start to see this information overlaid. It's giving me basically a system-wide look at all the parcels and all the easement areas, and I can continue to refine and define additional data sets and data sources. One way that I can kind of progress this out is I could certainly look at different proposals. So we'll look at proposals in a bit here, but I could certainly switch it and say, what does it look like in a different proposal? And I would end up seeing additional layers or other information that I brought in. Let's go ahead and, there we go. So the proposal is being kind of brought in here. And so here now you can see the same exact data set, but now we're seeing also the transmission line information. We're seeing locations for poles, and they've all been styled out. This is not so much a detailed design. This is very much a high level, I just want to look at this. I want to spend maybe 5-10 minutes doing this and have a high level system look at a complete design before I start my design. So that's one use case. I just want to look at a complete system. I want to bring data in. I want to overlay what the data I already have. We're going to go ahead and switch gears here. So hopefully that's kind of a good look at how Model Builder can work. By the way, that Las Vegas data set is now here. Just because of time, because we do have limited time, I'm not going to go ahead and work on that data set for today, but I now have it ready for my next time. The next use case that we're seeing quite a demand for is going to be around visually looking at what-if scenarios. And a lot of times it's about building something in somebody's neighborhood and having some need to show this to public opinion polls to get support for the project. So we're going to go ahead and look at a substation project, and we're going to do some wall analysis. What can we do to shield this substation project? So first thing I like to do is I like to have saved bookmarks. So I may have a full system, but I may want to look at a specific location within that system. So in this case, I'm looking at it from this angle, or I'm looking at it from that angle, and I can move around quickly by adding different bookmarks. Bookmarks are basically a saved view. I'm going to wait just a minute here as this model kind of catches up to my graphics. So a couple things too as we wait here for a minute. You will see that the sky is animated. These are things that we can turn off. We can certainly make it less realistic by removing that functionality. Additionally, within the different view sets, we can look at this in different ways. I can look at it from an engineering view, which again gives me faster speed because I don't have the sky animated. I can even create transparent styles where I can see below grade, above grade. So I definitely have different ways that I can view this model. So in this case here, we have a brick wall, and we're looking at different alternatives. So within my proposals, I can show different alternatives. For instance, the project may have started as a chain link fence. So by just switching proposals, we can go ahead and see this is what the project currently looks like. We have a chain link fence. This is basically the view from the street. How can we shield or hide this project or condense it? We could certainly switch it and say, let's go to a brick wall, and we may even add vegetation along the frontage here. So we have this ability to propose what-if scenarios that can certainly tell a different story. From this angle, from that angle. And this is very much something we can do very quickly. So for instance, I can go to decorative wall. Just change proposals here for a minute. And we can start to look at different options for our wall. So one way to do that is through our style palette. So I've already built a few different types of wall types. So I'm going to go ahead and drop in a gray barrier wall. We'll drop that on there. And we'll see that that wall now looks like a gray barrier. We can certainly change it to a stone wall. We can go through these different alternatives with how the wall might be shown and how we might design it. Here's a rock wall. I kind of like the stone wall. Bring it back. And then these are physical elements that are in the project. They're physically drawn in or sketched in, if you will. This is a barrier. This barrier has properties. So some of the properties might be its height. We can certainly raise that brick wall up to a height of 15 feet and update that. And now we start to see that wall in a different environment with a different height. So I wanted to kind of just show a very simple use case, which would be coming in and doing what-if alternatives and then saving them as different proposals within your project model. So this would give you the opportunity to present these out at different levels. So again, we'll bring it back to the original brick wall. This is all, keep in mind, this is all part of the same model. So we're not building different models, we're just building different alternatives within the same model. So that's two use cases we're looking at here. So Model Builder, add GIS layers. This is not Model Builder in this case now. We're looking at a much higher resolution imagery. We're looking at data that came from the source, the customer source. High resolution. We're also bringing in some other high-resolution data like substation models and modeled out poles. In this case, we have a pole here that's been modeled from Inventor. We also have a substation model that's been modeled in Inventor as well. So a couple different ways that we can start to bring this up. This is more of a design level model review, if you will. I'm going to go ahead and switch gears. I have more to show. So there's two scenarios, our planning level and then our detailed design review level. The next level model I want to look at is more around consuming data that the utility industry uses quite often, and one of those would be around pole design using a program called PLS-CAD data. PLS-CAD is a very refined software that does very specific calculations around conductor sag and pole design. And to take that data, how can I actually take that data and bring it into InfoWorks? Now, one way is that many times this data begins as a LiDAR scan. So I'm currently looking at this same data, but it's LiDAR. We're not looking at physical poles. We're looking at LiDAR data. This is one single cloud been defined. So we'll go ahead and look at this from a couple different locations. We'll look at it from here. We'll look at it over here, including even these street lights, the signal poles, signage. All this is coming from LiDAR. So if I have the ability to come in and make a change to the design, for instance, let's go over to this location where we might be removing poles and putting in new poles. So here's a scenario where we're going to probably remove this pole and we're going to actually put in a new span. So in this design scenario, which we'll go ahead and switch the proposal, we will see that we now have moved that pole out, and we're no longer just looking at LiDAR, but we have a physical pole. This is a physical element that's in here. All these poles have been modeled, including the conductor runs, which are also modeled. Now, how does that data come in? So I'm going to switch gears to Civil 3D for just a moment. And so this is that same set of poles. In fact, let's go ahead and go look at that location. Bear with me for a second. So this is the LiDAR of that pole. Actually, that's the physical pole. So there it is. That's a physical pole. Earlier we saw it as LiDAR. Let's switch it here. We'll look at it as LiDAR for a second. So there's the actual LiDAR, and then we have the physical pole. So the physical pole came to me as a DXF file, came out of PLS-CAD as a DXF, and then from this environment, which I currently have Civil 3D, this could also be happening inside of AutoCAD. I'm going to just go ahead and convert. And there's a command, and I love the command line on Civil 3D because I can actually just start, I think it's convert to solid. Convert to surface, actually. Can't find my command here. Convert to surf. Where is it? Here it is, convert to surface. So this command allows me to actually convert this DXF export into a solid object that is then consumable. I'll go ahead and do a couple of these here. Consumable inside of InfoWorks. And so in bulk, I could go ahead and grab a whole span of these and let that process, and then come back over here and then bring that data in as data sources. In this case, I'm bringing in specific information within this model. Let's go ahead and switch this real quick to the design, and we'll see that we have those poles brought in from the Civil 3D environment, or in this case, AutoCAD. So we have these conductors that have been brought in, and they've been brought in as 3D model types. So when we look at the data sources that I can bring in 3D models, which in this instance, I can create a a DXF, or I can create an FBX. I can create, all different types, even 3DS models, and bring those in, and I would have then physical models to represent those elements. So one way of consuming what we see a lot, which is PLS-CAD data, is to just bring that into your AutoCAD environment and convert that data. I believe these are converted already, so we'll see that those are now surfaced poles. Basically, they're surfaced elements that can be brought in as a DXF. They could bring in as a FBX, which I believe I used FBX in this case. So a workflow there. Now, part of this project also includes the need to understand what is occurring within underground coordination between utilities. And so this is, again, consuming Civil 3D data. I was able to bring in underground utilities in critical areas. We model in the critical areas, and now we have a look at where those pole locations are and how they're going to be installed or constructed, and then how they basically lie in place with the physical utilities that are underneath the ground. So coordination, utility coordination, which is a huge part of the requirements here for projects we deal with, having that data combined is very, very powerful. Now, one of the things that I might bring up here is that I'm still consuming a lot of that LiDAR data, just not the pole data. So when I come back down to a location like here, I'm still consuming in this model because I don't want to technically spend the time modeling out these signal poles, and these are very accurate to what's actually out there because that's a LiDAR of that actual street pole. I'm still consuming the LiDAR. So in doing that, how did I get that done? Well, I went into Recap, and inside Recap, I have the ability, graphics there. So just for the moment, I'm going to go ahead and turn down that. So inside of the Recap, I'm able to go ahead and consume some of the data and remove it. I can actually clean out data that's in here. I have a little bit too much going on at the moment. Let me shut down my PowerPoint for the moment. Probably have too much demand on my graphics card. So I can go ahead and do some cleanup inside of Recap. Recap is very powerful. Again, Recap, Civil 3D, AutoCAD, and InfraWorks is kind of a combination that I use quite a bit. So the ability to bring that in, clean up the pipe, basically remove certain poles, but keep the rest of the infrastructure inside InfraWorks as necessary. And then we can go ahead and analyze or review that. So in this case, I might just go ahead and do a quick storyboard run, see what's happening in the project. And so now I'm looking at those poles. I'm running down the road. I'm seeing the conductors. I'm seeing the new pole locations. I'm seeing all the other street culture that was captured in the fixed wing fly-through. And so here we have ability to go present this project to those extended stakeholders. I'm hoping there's no lag on the video at the moment. So here's another use case. Just go ahead and do utility coordination, consume your PLS-CAD data, present your system. All right, so
John,
getting a couple.
There is some lag on the
sir.
video. I just wanted to let everyone know. I'm sure from John's standpoint that video is smooth as butter, but from where we're sitting, it's kind of choppy.
Okay, yeah, I was afraid of that, so I apologize. We'll probably stay away from video for the remainder. So here I want to switch gears. So I'm going to go ahead and switch gears to something a little more interesting in terms of where InfraWorks has really developed into a design tool. Up till now, it's been pretty much visual. I can certainly change the way a wall looks, or I could, draw a wall in, or I could do trees, and I can do vegetation. So clearly, I have that ability. Here, I want to look at something a little different. First of all, let's just kind of navigate a little bit through this model so we can kind of see where we're at. Different vantage points, if you will. So this is a very large data set, several miles of model builder data as well as LiDAR data. And so I can certainly navigate through here at different levels. And so what I want to do is I want to look at a workflow. So we have about 20 minutes. We're going to walk through this workflow. The workflow will be around basically conceptual design for a tower replacement. So here's the finished product, if you will, or semi-finished product, if you will. How would I go about developing or rebuilding an access road that's maybe deteriorated and needs some redesign, and maybe a tower pad that is also deteriorating? So let's go ahead and look at this process. And I don't know in my past if I could have done this design in 15 or 20 minutes or less, but we're going to get real close to that. Let's see what happens here. So I'm going to go ahead and switch back to a different proposal, and I'm just going to go to existing condition. And we'll see that currently what we're looking at is basically model builder data, some imagery, and then some LiDAR. That's basically what we got. And so from here, I'm going to go ahead and start by sketching out. I'm going to sketch out a land area. So this is something that's within your InfoWorks 360. Land areas are basically just something that we can draw in. If you can pick points, you can do this. You can certainly be very scientific, or you can just sort of guesstimate, if you will. That's an engineering term. And you can pick a couple spots. So I'll just pick 4 spots for the moment. And so now I have this basically a start point, or a platform, if you will. And then from that platform, I want to go ahead and establish some elevation. So I'm going to go ahead and give this some elevation. We'll do something like 675. We'll go to this corner. We'll do same thing. We'll just make this flat for right now. And we'll bring it up to an elevation that we want to start with. And we'll just go ahead and see what's going to happen here. So 675. And then one more in the corner. Now, there's areas that I wish that we could do a little more. It would be a little more automation around this setting of elevations. Maybe it's enhanced since I've kind of researched it more so recently. So here's sort of a flat pad, if you will, that's underneath that tower. And we can go ahead and shape it and change it at any time. We can add vertices to it. I can add another vertex right there. I can certainly grab that corner and shape it over here. So very simple. It's very intuitive. It's not something that you have to be super expert in. It doesn't take years to develop the skill set to do this. So you pick your spots, if you will. And then to kind of refine the design, we can go ahead and apply something called a grading style. So go ahead and find that inside my style palette, if you will. And I'm not seeing it. Let's try this again for a second. Oh, it's a style rule. So sorry. I grabbed style rule right next to style palette. So if you're not familiar with the menu interface, this is an immersive interface. If you're used to your traditional CAD environments, and a lot of times with InfoWorks I tell people don't use it like CAD because it isn't CAD. It does work with CAD data, but it isn't CAD. And then the menus are a lot different than what we're familiar with on our day in, day out basis. So just be you got to get kind of comfortable with the immersive interface. What I was looking for was style palette. Grabbed the wrong one. So as we go down here, we'll see there's a tab for grading, and I built out a few more options, but out of the box, you'll have a handful of default grading options. And so out of the box, you could take something like 3 to 1 and say, well, what would that look like at 675-foot elevation if I was at 3 to 1? Quite a bit of grading. What would that look like if I went to 2 to 1 and used maybe rock? Right? What would that look like if I went with 1.5 to 1? And so you can continue to drop in these different ideas or different concepts. What would it look like if I did this? What would it look like if I did that? You have this ability to do this. What if we just go 1 to 1? And the interesting scenario here is that as soon as I do this, I'm going to go ahead and bring it back to the one I had just a minute ago, which I think was well, I'll keep it there. That's fine for now. I have now something that gives me my grading limits, but it also is something I can analyze. So again, immersive interface, we can kind of work from the left to the right. This is your Analyze Model tab and opens up your menus for analysis. And we have lots of different analysis here, many that I'm not going to touch on today, but solar, sun and sky analysis, point-to-point analysis. But the one I'm going to do here real quickly is terrain statistics. So a lot of times I'll spend a minimum of an hour or a half hour inside Civil 3D trying to get to this level. And all I really want to know is right away, what's my cut and fill? What's my 2D area? What's my 3D area? What's my volume? And so I'm seeing here that I'm at a different level of cut and fill. Certainly I can go in and start to refine that. Additionally, I'm going to go ahead and keep it for now, even though I'm kind of in a import environment. I want to look at, looking at my clock here, 9:46, I want to look at how would I then design in an access road to this. So I'm going to go ahead and switch gears to my road design tools and just going to do something very simple. I'm not going to worry about the style that I'm using, or will I? Let's see, I'll just grab something. Here's a sand road for now. Rock road's fine. And I'm going to go ahead and pick a spot, and I'm going to set speed. So this is an access road, so at most 15 miles an hour, probably even less than that. And I'm going to pick some locations here as I go through, as I go to redesign or rebuild this access road for the transmission tower. And so what I'm actually using is design criteria, AASHTO design criteria, in fact, and I'm building out basically a road. Now this road is truly design tool, so it has the ability for us to go ahead and look at it in profile view. It has the ability for us to go ahead and add in points of vertical inflection, or PVIs, vertical curves. So as I push and pull this vertical profile, I'll put another PVI in here somewhere else here. Let's say right here, we'll add another PVI, drop this down. That's going to be a little crazy. And just go ahead and let that go. And then we'll see that reflective design right here inside of InfoWorks. So I've got kind of a roller coaster road, but just showing you that I can go ahead and lay out an early stage design concept, and then we can take it a little step further. I'll just kind of cheat a little bit and show you my design that I prepared for this presentation, which is this design. So I have two things. I have a grading pad, I have the design road, and from there, I'm going to take that information over to Civil 3D. My trusted switchblade, Civil 3D, that I use all the time. And what I'm going to get inside of Civil 3D is I'm going to get terrain data, which I clipped back a little bit, but this is the surface terrain that came from my InfoWorks environment. So there's my terrain data. I may have graphically gave myself a little bit of a heart attack. There it is. So there's my my terrain data, but I'm also getting actual design alignments. These are true Civil 3D alignments, and they're true Civil 3D profiles. So I now have a profile design which is editable. I can fine-tune it here, right? I can change the design, make it what I want it to be, alter that out. I can document it. So here's my plan and profiles, if you will. And then from there, refine the design through to a true corridor model. So we'll go ahead and build a corridor model from this data, refine it out, and then ultimately we will have a design that represents that access road, where we could then blend that out, build surfaces, and then take our project further. In other words, start in InfoWorks, bring it to Civil 3D, do our detailed design, document, and then ultimately bring that back, round trip that all the way back. So let's go ahead and take the Civil 3D data, which I can bring straight into InfoWorks. And by the way, as that's happening, to bring InfoWorks into Civil 3D, it's pretty quick now. You can go straight to your Insert tab, and right here you now have an InfoWorks 360 basically importing functionality right in your ribbon. This is seamlessly developed to work together. these two tools work together. Take the same data and bring it into another platform in this case. So here we are. Now we're looking at the true Civil 3D model that I built in Civil 3D. I refined this grading pad so that I could actually balance my cut and fills. I went ahead and designed my road so I have true grading the way I want it to be based on my design criteria. And then ultimately, I can then supplant this or augment this a little further. In this case, round trip in my recap data. So remember recap, I cleaned up my cloud. I'm going to go ahead and grab that cleaned up version. And I'm going to let that catch up for a second. I'm going to go ahead and configure this, basically just telling it where it needs to go in space. And we'll now see, hopefully if I cleaned it up enough, I don't know if I got all the points out I wanted, but I got most of them. I've spent maybe 3-4 minutes cleaning up the cloud. And so I'm now looking at the cloud as well as my design on top of my model build terrain. And then I added a tower to because this tower is being redone. So we dropped in a new tower. This is basically just an element within my InfraWorks, and I'm bringing it in and consuming all my data that I have. Hopefully you see that as being very cool. So again, starting from existing with LiDAR, which in this case was a very short amount of time. Model builder was under 5 minutes. The LiDAR was processed and recapped in about 10-15 minutes and brought together in a few minutes. And then I was going to then do a concept inside of InfraWorks. How would I design that road? How would I design that pad? Again, very quickly, kind of laying it out fast. And then ultimately taking it to Civil 3D to refine it, cleaning up my recap model so I can see the design in context with the as-is. And this project, probably from start to finish, is something you could do in under an hour. So let's go back to the PowerPoint if we can for a minute, just because I do have a few things to add here before I switch over to Eric. Got a few more slides here that I wanted to share. The real reality of this is, what does the benchmarking look like? And that's been kind of the key here. How long does it take to do something in a reasonable amount of time? If I have all the data gathered together and it's proprietary data and it's all in the same GIS space, you could do that very first model with the PLS CAD data in under 30 minutes probably. Maybe not your first project, you can probably spend 40 minutes kind of trying to figure it out. But basically you start with your new model, you import your terrain data, you import your aerial imagery, you bring in any GIS data, in this case maybe some parcel data, you drop in your PLS CAD poles and conductors coming from an FBX, you bring in building data if you need it or have it, you bring in your LiDAR and you save a bookmark and you're on your way. Looking at some of these benchmarkings, cleaning up LiDARs, typically fairly short if it's not too detailed of cleanup, if it's not surgical. You can usually clean out big swaths of data pretty quickly. Building, like modeling a pole, it depends on your performance of your hardware, but typically the models I did were under 15 minutes to kind of just take it into Civil 3D and model those poles from the DXF. Same thing with the conductors. The underground utility is a little different. We have a lot more complexity, so it could, a lot of times the as-is or the basic data that you have related to what the design or the original design was is hard to find and locate and gather together, so there's a lot of time spent there. But once you're in Civil 3D and modeling, it's not a super amount of complexity if you know where you're going and what your inverts are and your size and materials. So that's kind of a high ground level of that. So I want to thank you for your time. I'm going to switch over to Eric here in just a minute and let him introduce anything else he wants to do for our next webcast.
John,
Thank you very much.
thanks, John. We had a couple of questions. I don't know if you're interested in taking a few of those.
Certainly.
There was a question, and I'm going to go back a bit to your first example, which was before the point cloud information. The electrical components that you had in that model, I know you showed in one example that you modeled them using Civil 3D. Were there, and I think you mentioned one of them came from Revit as well. Are there other places where you can get or model or create these components?
So with my customers, we are definitely leveraging Inventor Professional in conjunction with Vault as their design standards for their 3D model design standards. And this is around transmission poles, both wood and steel poles. And so we are seeing a high interest and focus around developing 3D standards on Inventor in our space, and this is with back-end intelligence on that. And then on the second part, the substation model you saw, it is a substation model designed on top of Inventor platform as well. It's using a partner solution that's built on top for the substation design portion of it. Okay. And it's also, by the way, tied to AutoCAD Electrical for all the detection and control. So this is a true BIM for utilities workflow. I'm only focusing on the InfraWorks part of it in this case, though.
Right. Yeah, and that actually answers another question: is where the substation was created. Now, some of the model components were created in InfraWorks, like the brick wall that you showed. Was that created using the barrier tool in InfraWorks?
It was. It was a barrier. I used a fence barrier, and I used a brick, wall brick barrier, and then just apply styles and heights. The tower that you saw in that last example was just out of the box from InfraWorks. It's a tower that's included, but you can certainly go get other towers and bring those in. Lots of different ways and areas to get them. Some models I would call non-intelligent models. They're just physical 3D models of the shape and dimensions, and others are intelligent where they have metadata attached to them.
Okay. And we had some other questions. We're nearly out of time, but those questions all get logged in our register, so perhaps we can follow up with some of you later on with email answers to some of the questions that you asked prior.
Absolutely.
I'm going to take back presenter status for just a second. Bear with me. And I just want to remind everybody that our next webcast coming up is, once again, what's new in the geotechnical module in Civil 3D 2018. We're going to be hearing right from the folks who developed the technology for this module. So kind of back to the core values of our product webcast series, where we'll be hearing from the people who generate the technology themselves. It's going to be a really exciting webcast. This is an amazingly powerful module. If you haven't used it before, it's definitely worth checking out. And I also know that there are some big changes and improvements that have come about in this latest version that actually isn't released yet. It's going to be out soon, between now and the time of the webcast, as I understand it. So with that, I'm going to thank everyone for coming. Thank you, John, for a really amazing presentation. I know I learned some things I didn't realize were that easy to do with InfraWorks, and I hope, well, I know that some of you, just looking at some of the comments in the questions panel today, there were some really folks that were really impressed with what you presented. So thanks for doing that and educating all of us in an industry that maybe we don't think about using InfraWorks in every day. So. Thanks again, everybody. Have a great day, and we hope to see you all back in 2 weeks for our next webcast. Thanks.